Welcome to Learning Path 6, Implement Security and Validate Codebases for Compliance. In this session, we'll explore how modern DevOps practices strengthen software security from the ground up, starting with secure development habits, thoughtful use of open source components, and continuous visibility into code quality. Along the way, we'll look at how monitoring and governance reinforce these concepts so that we can confidently design secure pipelines, improve compliance, and build solutions that stand up to real-world challenges. Security is everyone's responsibility, and it's not just a one-time task, it's a continuous journey. Securing applications means thinking about protections at every stage, from the infrastructure that runs our code to the architecture of our app, and all the way through to ongoing monitoring and validation. Imagine security as a cycle. You start by building a strong foundation, a secure infrastructure, then design our app with layers of defense, continuously validate that those defenses are working, and always keep an eye out for attacks. This holistic approach ensures that vulnerabilities are caught early and that our systems stay resilient against threats. So why does this matter for DevOps teams? In today's fast-paced development environments, security can't be an afterthought. By weaving security into every phase, the planning, the building, the deploying, and monitoring, we help safeguard sensitive data and maintain customer trust and meet compliance requirements. Continuous security validation means we're always checking and improving rather than waiting for problems to surface. This proactive mindset empowers teams to deliver reliable, secure applications and respond quickly to new risks. Let's look at an example of a security threat that, if we aren't careful, can be exposed in our code. A SQL injection attack is a serious security vulnerability that targets web applications using SQL databases. Imagine a simple web app that lets users interact with a database. If the app doesn't properly validate user input, an attacker can sneak in malicious SQL code through a form or a URL. This code tricks the database into revealing sensitive information, modifying data, or granting unauthorized access. For example, if a business user needs access to customer data stored in a database and the app exposes the database directly without safeguards, it opens the door for attackers to exploit this weakness. DevSecOps is the fusion of development, operations, and security, bringing these disciplines together to build safer, more resilient software instead of treating security as an afterthought. DevSecOps weaves protection into every stage of the development process. The goal is simple: empower teams to move quickly without introducing vulnerabilities. This means implementing strategies like access control, hardening environments, and perimeter protection, so security becomes a natural part of how we build and deploy applications. Think of DevSecOps as a collaborative mindset where everyone shares responsibility for keeping systems secure. So why does this matter? Well, we live in a fast-paced world, and software often relies on third-party components, which can introduce risk if not properly managed. And DevSecOps asks important questions. Are the packages we use secure? How can we detect and fix vulnerabilities? And by integrating security checks and rapid response mechanisms, we can spot issues early and remediate them before they become serious problems. Adopting DevSecOps practices helps teams deliver reliable software, maintain customer trust, and stay compliant with industry standards, all while keeping innovation moving forward. The secure DevOps pipeline is designed to make sure that every piece of software added to our release process is safe and trustworthy. It starts with package management, which controls how software packages are brought into the pipeline and ensures that they go through an approval process before being used. This means that only vetted packages make it into our application, reducing the risk of introducing vulnerabilities. Another critical part is the source scanner, which automatically checks our application source code for security issues. By scanning for vulnerabilities early, teams can catch problems before they reach production, saving time and protecting sensitive data. In DevOps, continuous security validation is essential at every stage of the development lifecycle. This slide here illustrates how validation and feedback should be integrated from the moment the code is written into the IDE through all the pull requests and continuous integration and development and testing. Each step, whether it's static code analysis, unit testing, infrastructure scanning, or performance testing, serves as a checkpoint to catch vulnerabilities and ensure quality before software moves to production. By embedding these validation points throughout the pipeline, we can detect issues early, reduce risk, and maintain a secure, reliable release process. Why does this matter? Well, security threats are constantly evolving, and a single missed vulnerability can lead to costly breaches or downtime. By making the validation a continuous process, Organizations empower their teams to respond quickly to feedback, fix problems before they escalate, and build trust with our users. This proactive approach not only strengthens security, but also strengthens our development and helps us streamline it. It helps teams deliver robust applications faster with greater confidence. Continuous security validation is all about catching vulnerabilities early and reducing the cost throughout the software development lifecycle. This slide shows how the cost of fixing a defect skyrockets as we move from coding, which is around $80 a defect, to build and Q&A and security, and finally production, where they're showing an average of $7,600. By shifting secure DevOps practices to the left, meaning earlier in the process, teams can use automated tools and processes to identify problems before they become expensive headaches. This proactive approach not only saves money, but also helps maintain the integrity and reliability of our applications. We all work in fast-paced environments. It's easy to overlook security until the end, but that is risky and costly. Continuous security validation means integrating checks and automated testing at every stage, from writing code and deploying it into production. This empowers teams to deliver secure, high-quality software quickly and respond to new threats and build customer trust. Ultimately, making a secure, continuous process ensures our applications stay resilient and compliant while streamlining the development and reducing last-minute surprises. Threat modeling is a proactive approach to securing applications by identifying and addressing potential risks before they become real problems. The process starts by defining security requirements for our project, then creating a detailed application diagram to visualize how different components interact. The visual map then helps teams spot areas where threats might emerge, such as insecure data flows or weak authentication points. By systematically identifying threats, we can prioritize which risks need to be mitigated first, ensuring that our application's defenses are both targeted and effective. Once threats are identified, the next step is to implement mitigation strategies and validate those threats have been addressed. This means putting safeguards in place like encryption, access controls, or secure coding practices, and then testing to confirm that they work as intended. Threat modeling isn't a one-time task, it's an ongoing process that helps teams stay ahead of the evolving security challenges. By regularly revisiting our threat model, we can adapt to new risks and maintain a strong security posture, ultimately protecting our users and our organization's reputation. CodeQL is a powerful tool that treats our code base like a searchable database, allowing us to run queries to uncover potential security vulnerabilities and bugs. Instead of manually combing through thousands of lines of code, CodeQL lets us ask targeted questions like, are there places where user input isn't properly validated, and instantly get results. The process starts by creating a CodeQL database from our code, then running either a standard or custom analysis queries against it. This approach makes it much easier for development teams to proactively find and fix issues before they reach production. One of the biggest benefits of CodeQL is its flexibility. We can use the CodeQL command line interface, or CLI, to integrate it directly into Visual Studio Code for a seamless workflow. By interpreting the results of our queries, we gain actionable insights into our code's security posture. This is especially valuable in environments like GitHub, where the automated security checks can be built into our CI/CD pipelines. Ultimately, CodeQL empowers teams to maintain high standards of code quality and security, making it an essential part of modern DevOps practices. Now that we have discussed how to manage packages securely, let's discuss a common source of software packages: open source software. Software is rarely built from scratch. About 80% of our applications are made from components sourced from internal teams, commercial third parties, and the open source community. This means that nearly every piece of software we use today relies on open source software in some way. By combining these components, developers and teams can innovate faster, reduce costs, and tap into a global pool of expertise and resources. Open source software is a special kind of computer program where the source code and instructions that make it work is freely available for anyone to study, modify, and share. This means that instead of being locked away by a company, the code is open for the community to improve, adapt, and distribute for any purpose. Open source powers many of the technologies we use every day, from operating systems like Linux to programming languages such as Python and JavaScript. By making the code accessible, open source encourages innovation and collaboration, letting developers worldwide contribute with their expertise and creativity. Open source software brings incredible flexibility and innovation to our modern development, but it's important to recognize the potential risk that comes with using these components. Sometimes open source code may be of low quality. which can impact the reliability and maintainability and the performance of our entire solution. If a project isn't actively maintained, it might not evolve with new requirements or security updates, forcing our team to fork the code and take on extra work. There's also the risk of malicious code. If attackers slip harmful code into a widely used library, it could compromise not just our application, but the whole company's IT infrastructure. Security vulnerabilities and licensing restrictions are other major concerns. The security of our system is only as strong as its weakest link, so using open source code with known vulnerabilities can make our application an easy target for hackers. Licensing issues can also arise, as some open source licenses have restrictions that might not align with our intended use or potentially affect our entire solution. The key takeaway is that while open source software offers great potential, DevOps teams must stay vigilant and actively assess its quality, maintenance, security, and licensing to harness the benefits while minimizing the risks. Open source licenses represent the legal stance of open source software, defining how the code can be used, modified, and shared. According to the open source definition from opensource.org, a valid open source license must be fair and inclusive. It cannot discriminate against any person or group, nor can it restrict usage based on a field of endeavor like business, research, or education. This means open source software is designed to be accessible to everyone regardless of who they are and what they plan to do with it. Open source software comes with a variety of licenses, each setting different rules for how the code can be used, modified, and shared. On this slide, licenses are grouped into three main categories: attribution like BSD, MIT, and Apache, downstream such as MPL, EPL, and MSRL, and copyleft including GPL, LGPL, and AGPL. Attribution licenses are generally permissive and they allow us to modify and redistribute the code as long as we give credit to the original authors. Downstream licenses add requirements for sharing changes or improvements, while copyleft licenses are the most restrictive, requiring that the derivative work is also distributed under the same license. When using a software package, especially one that's open source, we are agreeing to follow its license requirements. These licenses can have high, medium, or low impact on how our distributed software operates. For example, some licenses might restrict how we share our software, require us to credit the original authors, or even limit commercial use. Understanding these requirements is crucial for DevOps teams as it helps avoid legal pitfalls and ensures that our project remains compliant with intellectual property laws. License ratings go a step further by indicating the overall impact of using a package. They help us quickly assess issues like compliance, intellectual property rights, and exclusive rights associated with a package. By checking license ratings, we can make informed decisions about which package to include in the projects, balancing innovation with legal safety. This process not only protects our organization, but also streamlines development by reducing the risk of future complications. Let's go to a demonstration of how we handle these threats. We can visualize our solution's threats using tools like Microsoft's threat modeling tool. Here we can label our resources, our trust borders, and the path our data travels, ensuring encryption at rest and in transit. It also informs us where we can optimize networking and processes safely. Adding a new resource is easy. Just drag the icon onto the canvas. Once there, we can integrate it into our solution. In GitHub, we access our security configuration through repository settings. We can choose which reporting tools are active and configure dependbot features. In Azure, we can access Microsoft Defender for the cloud. Here we can set up our environments, view recommendations, investigate path analysis, and view security alerts. Cloud Security Explorer allows us to query our resources and includes many query templates to choose from. The Workbooks tab shows our Defender workbooks and quick starts for customization. Here we see the DevOps Security Workbook. and we see a large community is available for information and to contribute to. Microsoft Defender for Cloud includes a robust troubleshooting guide. We can also track our security posture and regulatory compliance, workload projections, and data and AI security. And here we can investigate our network security and create tools to mitigate tasks. In the DevOps security section, we can connect to our environments and set the policy and governance rules. We can set per environment rules and exemptions here as well. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning /MSLearn-DevOps. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.